My name is Philip Heedy. I'm a product manager on the ArcGIS Enterprise team, and for the next 60 minutes or so, I'll talk about ArcGIS Enterprise and how to architect your deployment. So this is not a very GIS-y presentation at all. I'm not going to do any live coding, sadly. That's another presentation. I'll talk about how to architect and plan for deploying ArcGIS Enterprise. ArcGIS Enterprise, as you heard about this morning, is the software version of the foundational ArcGIS platform. The alternative is, of course, ArcGIS Online, which is the SaaS offering. And the reason I have to stand here for the next 60 minutes to talk about architecting and planning an ArcGIS Enterprise deployment is software you need to install somewhere. You don't just get to magically log into a website that's already there and being taken care of by somebody else. Sometimes I'm a little bit jealous. Nonetheless, we'll have hopefully an enjoyable 1 hour together. I want to start by talking a bit about some of the assumptions and prerequisites that I'll make during the presentation. It is going to be a beginner presentation in the sense that I will try to start from the beginning. But if you have some of these prerequisites in place, you're really well suited to be able to follow along. If you're familiar with ArcGIS Server, you've been using it for many years and you know some of the key terms and concepts there, such as an ArcGIS Server site, you'll be in good company here with the rest of us. If you've already worked with Portal for ArcGIS, or you know the concept of a portal, that will also help. But I'll talk about the different components that make up ArcGIS Enterprise. I always like to get a feel for who I'm talking to. So I'll try by show of hands. I'll get you going again here after having food over lunch to tell me who you are. This is the Developer Summit, so I'm going to try to see if I can validate my assumptions. How many of you routinely, as the primary function of your job, deal with architecture and system design? By show of hands. You're in the right session. How many of you are developers? You write code, custom applications. How many of you had your hands up both times? Right? We all wear many different hats. So that means that you're not just familiar with the actual system architecture, the design, the deployment of the software, but you also use the software. So this is very much on the actual conceptual side of things. I'll touch a bit on some of the deployment automation tools at the end of the presentation. How do I turn my architecture, my design into something that actually gets installed on a physical machine, on a virtual machine, in the cloud, wherever it may be? I want to get this out of the way. It's going to be relatively fast-paced. I'm going to throw a lot of new terms and concepts at you. If you're not already familiar with them, don't panic. I couldn't use the obvious graphic here for copyright reasons. All right, keep that in mind as we go through the session. The first thing I want to do is talk about the software components that make up ArcGIS Enterprise. We talk about ArcGIS Enterprise as this one singular thing. It's the product. But at the end of the day, once you get down to the business of installing software on boxes, on VMs, in the cloud, there are multiple software components that make up ArcGIS Enterprise. ArcGIS Server has been around for a long time, and I'm going to assume that many of you have been using ArcGIS Server throughout many of those years. But it's by far not the only component of ArcGIS Enterprise. There's also Portal for ArcGIS, there's the web adapter, and then there's ArcGIS Data Store. And these four components together, when configured appropriately, make up what we refer to as an ArcGIS Enterprise deployment. The reason I point that out is it's a common question, especially when I talk to somebody who's new to the Esri platform. If you go to My Esri and you look for the ArcGIS Enterprise download, there is no such thing, right? On the other hand, you will find these four things under the ArcGIS Enterprise section. So how do we actually put these together? Take these four components, do an architecture. Well, first we have to dig a little bit deeper. We actually want to know what are the capabilities of the individual components. You heard about a bunch of different capabilities in the plenary this morning. You heard mention of things like GeoAnalytics Server, You saw some demonstrations of the big data processing capability that it brought. You also saw Vinay talking about raster analytics and doing work that was powered by Image Server. GeoEvent is where we have real-time processing, and then we have the traditional workhorse of the system, the GIS server itself, that does mapping, routing, geocoding. Just like with ArcGIS Enterprise itself, you won't go to my Esri and find a download called Image Server or GeoAnalytics Server. You will find the one download that's called ArcGIS Server, and then that one software component, depending on what license file you apply to it, turns into a GIS server that can do mapping, a GeoAnalytics server that can do big data processing, and so forth. That's also an important thing. There's this one software component that can do lots of different things depending on how it's licensed and configured. There's a little asterisk next to GeoEvent Server because there is actually an overlay called GeoEvent Server that you will download and install on top of the ArcGIS Server software component. Okay. One software component, multiple server roles. If you have been working with ArcGIS Server itself for a long time, predating the introduction of this concept of the portal and the WebGIS geoinformation model, you may be familiar with a more traditional setup that just consisted of ArcGIS Server itself, often with a web adapter in front. When I talk about an ArcGIS Enterprise deployment, I'm fundamentally talking about the deployment model on the right-hand side of this diagram. This is where there's a portal for ArcGIS component, along with ArcGIS Server, along with ArcGIS Data Store, and those web adapters. So if you're moving from a traditional standalone server model to ArcGIS Enterprise, you're going from something that looks like what's on the left to something that looks like what's on the right-hand side of this slide. So let's try to deconstruct that right-hand side diagram, the base deployment of ArcGIS Enterprise. There we go. You see these 4 different components together, and there's a bunch of lines signifying a relationship between the different components. When we look at the left-hand side here, we have the ArcGIS web adapter. The web adapter is a fairly simple software proxy that sits in front of the other components and deals with things like security integration. If you're in the Microsoft world, this is the component that handles integrated Windows authentication if you have a classic Active Directory setup and you want to make use of your existing domain accounts. If you're in a Java or Linux world, this is where we will do integration with your LDAP. It's also where we can do a lot of configuration and make sure that the traffic going to the backend components go to the right places with the right information attached to it. So all this is really just a software proxy that we have implemented that knows about the ArcGIS Enterprise components on the back end. The next component of the base deployment is Portal for ArcGIS. Now, something that I want to point out early here is also, right now I'm talking very much in terms of the individual software components, because we're literally talking about how do I put that software component on the right box, the right VM, and whatnot. That's an administrator-centric way of looking at the system. For the most part, if you are looking at the system from a user's perspective, they don't need to know about the individual components sitting on the back end. So if you look at user-centric documentation, hopefully you won't find any references to Portal for ArcGIS. We will talk about things like the Enterprise portal. I make that distinction because we are trying very hard to talk to the right audience with the right terminology. And you, right now, are wearing your architect and administrator hats. And that's where we talk in terms of software components. I don't want to know about Exchange servers when I'm opening up my email client. Just like the users of the system shouldn't have to know about Portal for ArcGIS or ArcGIS Server or data stores. All of that is a back-end story. So with that out of the way, Portal for ArcGIS is that software component that powers the front end of the system that many of you saw in the plenary this morning, where a lot of users will go in and interact with the system, create their maps, create their applications, their story maps, things of that nature. It's also the software component that powers the web services that power all of those applications. This is where things like user, group, and item management takes place within the software. Sitting behind the portal itself is some form of ArcGIS Server. In this specific case, as part of the base deployment, we always have a GIS server. That GIS server has another mission in life that I'll define a little bit later on called the hosting server. I'll explain what that means in just a little bit. This is the workhorse of the system. When you're doing analysis, when you're asking the system to draw a map, when you're asking the system to compute a route, that computation has to run somewhere, and that somewhere is the ArcGIS Server software component. Attached to the hosting server is the ArcGIS data store. The ArcGIS data store is an ArcGIS managed data repository. It stores data that you hand over to the system. Now, a common question when I talk to new users of ArcGIS Enterprise, especially those of you who've been around for a while, is, does this replace my enterprise geodatabase? The answer is no, it does not. Emphatically no. This is the repository for data that you hand over to the system, as I said. When somebody logs into the enterprise portal, drags and drops a CSV file onto a map, and magically it shows up as a bunch of points that they can then perform analysis against. What happened behind the scenes is that data had to go somewhere. That somewhere is the ArcGIS data store. The data had to be drawn by something or passed back to the client somehow. The component taking care of that was ArcGIS Server. And the actual map viewer itself, the web application that you were interacting with, came from the portal. The reason I pointed out is that your enterprise geodatabase plays a completely different role inside of ArcGIS Enterprise. That is where you are managing data in your own system of record in many cases. It's where you have your own SQL Server, Oracle, Postgres, whatever your database of choice may be, and you attach it to the system and reference the data in place. We don't suck the data out of the database and take it over. You're still managing that through regular workflows such as managing it from ArcGIS Pro, ArcMap, or any number of third-party clients that can do SQL access. The data store is not in competition with that. The data store is there to take all that other data that gets generated by the system or gets handed over to the system. When we talk about the ArcGIS data store, it actually consists of 3 different types of data stores. What I just described right now is the relational data store. Think of it as a built-in geodatabase. There's also 2 other flavors of the ArcGIS data store. One of them is the tile cache data store, highlighted here in white because that's also part of the base deployment. The tile cache data store is simply the place where we store 3D scene tiles. So when you generate a scene layer, we store that cache of all those 3D tiles somewhere, and that is the tile cache data store. The third flavor of the ArcGIS data store is the spatiotemporal big data store. I'll get back to that later on in the presentation. But for now, I'll just mention that it's not part of the base deployment. The spatiotemporal big data store supports a number of other more advanced capabilities that you can add on to the base deployment of ArcGIS Enterprise. All right. The definition of the base ArcGIS Enterprise deployment that I just went through is also in the documentation. Everything that I'm going to talk about here in this presentation is something you can find in the documentation. So if you want to go back and talk to your staff after this, you can point them to enterprise.arcgis.com and go to the introduction pages. You will find this definition. It lays out the relationship between the different components, how they fit together, and what makes up the base deployment itself. What can you do once you have the base ArcGIS Enterprise deployment. What functionality is now available to you? It's everything that traditional ArcGIS Server did and has always done. I already mentioned a lot of this. This is the ability to publish your own map services, not just based on data that you turn over to the system, but referencing those enterprise geodatabases in place, other data sources that you have attached to the system, file geodatabases coming from file shares, or even folders of shapefiles. How many of you have folders of shapefiles? I have my I Heart Shape sticker on my laptop, and I think you should get one too. You can also publish content for other types of services. It's not just all about mapping, even if that's a big part of it. This is also where you can publish out things like your own geocoding services, if you have a locator available to do so. You can also do self-service mapping once you have the base ArcGIS Enterprise deployment in place. So this is where you can now give people in your organization access to some really powerful GIS capabilities without necessarily giving them the full power of the desktop applications. Without needing ArcMap or ArcGIS Pro, they can log into the enterprise portal and do a lot of things within the map viewer, such as dragging and dropping that CSV file on there, working with their Excel data, working with GeoJSON data that you saw Jeremy demo this morning. Once you have all of these data sources in place, you can also create configurable apps, story maps. You can use the web app builder that's built into the portal, and you can create your own set of applications using the many APIs and runtime SDK variants that we have within the platform. All of this is part of what you can do with the ArcGIS Enterprise base deployment. So how would I go about creating or setting up that base deployment? I'll go through this fairly quickly. Step one is to configure the web adapters. Install them and set them up. You hook them up to the software components that you have installed on a machine somewhere. On one machine, multiple machines, that's what we'll get to next. Once you have hooked up the web adapters, you will get to the next step and configure the ArcGIS data store and register it with your server. Meaning you're creating that connection from that component on the bottom. Now that you have your data store configured with your server, you will federate that server with the portal. I need new batteries. Once you have federated your server with the portal, and federation is this concept of establishing trust between the two software components, you will mark that server as your hosting server. Basically, you're telling the portal, the next time somebody comes around and hands you some data, they upload a file geodatabase or a shapefile or a CSV, I'm the server that you need to hand that data over to so I can publish it, store it, and serve it out. Now that sounds awfully easy, right? How many of you have tried to do that before by hand? I apologize. But even before you get to the deployment stage, there's something more that you need to decide. First of all, you need to choose a pattern of implementation. Are you going to install all of the software components on a single machine? Or are you going to split the software components up across multiple machines or a multi-tier deployment? That is step one because that's a very foundational choice. That will determine a lot of things going forward. It will determine how you install it. Which tool do you use to install it? Because, and I'll do a little preview, you should never do it by hand. There's a lot easier ways to do it. Jay touched on that in the plenary here at the end as well, and I'll talk a bit more about that here later on. As you're making this choice of a single machine deployment versus a multi-tier deployment, you need to keep in mind what those three different tiers of the system really represent. If you want to think of it in more traditional IT terms, you can think of the portal for ArcGIS tier as the web tier. That's your application front end, or ArcGIS Server is that app tier. That's where the computation is running. And finally, ArcGIS Data Store is your data tier. The reason why it might be useful to think in those terms is that will start guiding your thought processes around what are the different needs of these different tiers. Some of them are CPU intensive, others are storage and I/O intensive, and that's the thing you really need to keep in mind. So let's take those 3 tiers one by one and talk about how you can scale them and how you can put them together in a number of different ways. If you're looking at the portal tier, how do you scale that out? And when do you need to scale it out? The answer is fairly rarely. The portal tier is not very CPU intensive. It uses a little bit of memory, and depending on how many users you have and how active they are in interacting with the system, you may need to add a little bit of memory every now and again. But that's really the majority of use cases. The portal for ArcGIS tier in ArcGIS Enterprise does not scale out horizontally by adding additional machines. The way to scale out portal is simply to add some more resources to the machine that it's running on. Now we have high availability options that does add additional machines. You can add a secondary portal for ArcGIS machine, but it's for high availability. It's not for scaling out. It's not an active system in the sense of one machine can do all of the work. There's still dependencies within it. So the act of scaling out portal for ArcGIS by adding that second machine in an HA or high availability setup is really not how things are done. If you do need to scale out, you need to beef up the machine that the portal is running on. It's a different matter when we look at the server tier or the app tier where ArcGIS Server is running. Why might you need to scale out the ArcGIS Server hosting server site? Well, one thing that I haven't mentioned yet is that duality of what the hosting server site within your enterprise deployment really is doing at this point in time. It's powering 2 very different missions in life. It's both handling those hosting server duties that I talked about, performing analysis against data that gets uploaded to the server. When somebody goes and clicks the analysis button within the map viewer, that's the computational engine that gets started up. It's also where Insights for ArcGIS, as an example, will run its computation. So it does a lot of different things. If this is the only ArcGIS Server site you have in your deployment, this is also where you will be publishing your own map services too. Dynamic map services that are referencing data from your enterprise geodatabases, which means this is where a lot of maps are going to be drawn. That's a CPU intensive thing. If you need to be able to scale to handle large amounts of requests, high load, then this is where you might need to scale out your hosting server site, or as we'll talk more about here in a second, maybe even add a completely separate site to handle those other tasks. So hosting server resources can become an issue for a number of different reasons, and it's something to keep an eye on. When you do need to scale out, you have 2 different options. One is you can simply add more resources to the existing machine that you have. Or you can add additional machines to the hosting server site. ArcGIS Server scales both vertically by adding more resources and horizontally by adding additional machines as needed. So you have those 2 different options. This is where the choice of how you deployed your base deployment to begin with starts to matter. If you deployed everything on a single machine, then if you're now adding a second machine to just scale out one of those tiers, they're not balanced, right? One machine is running all the components, another machine is only adding to the app tier, only adding server resources for that middle tier of your system. That's where if you make a decision up front to split your base deployment, the components across multiple machines, you will have an easier time scaling out individual pieces of the deployment horizontally. The next part of the base deployment is that data tier. So when do you need to scale out the ArcGIS data store tier itself? Remember, there's a couple of different flavors of the ArcGIS data store that makes up the base deployment. The relational data store is where that vector and tabular data that gets handed over to the system or gets generated by the system is stored. And then the tile cache data store is where those 3D scene layers, that cache is being stored. So you need to think about what is your usage pattern. How many 3D scene layers are your users going to publish? None or many or somewhere in between? This is a fairly text-heavy slide, so when you're taking your photos or referring back to this, I want to be able to give you a little bit of context and things to keep in mind. But it basically boils down to how many users are going to be adding data to your system and how are they going to be consuming the data coming from the ArcGIS data store. In particular, the relational data store can get very I/O heavy. The tile cache data store is a little bit more interesting. You will see spikes of CPU and I/O when you're publishing a new 3D scene layer, but once that cache has been generated, it's very simple I/O to simply read a bunch of data and stream it back to the clients. So it's not so much the ongoing consumption, it's the act of publishing that impacts the tile cache data store. Data tiers can be tricky. You should monitor for what bottlenecks show up in your particular systems. If you're doing a lot of 3D publishing, you will have to keep both CPU and memory in mind. For most regular workflows, memory and disk I/O are really the important metrics to keep in mind. I have this note here about pre-10.5.1 versions. I didn't ask at the beginning how many of you were on which versions, but I'm going to assume there's a broad cross-section of different versions in use amongst you in the audience. Pre-10.5.1, the ArcGIS data store does not always handle out-of-disk space conditions in a graceful manner. My advice would be, don't get into an out-of-disk space condition in the first place. Monitor your systems. Some of you are chuckling. That's a very real thing. If you do get into an out-of-disk space situation, 10.5.1 and higher deals with it in a much more graceful manner by going into a read-only mode prior to that out-of-disk space condition. Should try to prevent data corruption. That's also something to keep in mind after this phase of architecting and deploying, that ongoing maintenance, the operations, is all about keeping an eye on your machines and making sure that things like this does not become an issue. All right. I said I'd talk about deploying a little bit. Once you've gotten into this mindset of thinking about the different components, you're thinking about whether to deploy on a single machine or maybe do it across a multi-tiered, multi-machine deployment. How do you do that? Well, first of all, I already asked how many had tried to do this by hand. If you wanted to set up a base deployment by hand, we have a tutorial within the help system itself. So those nice little lines that I showed earlier about hooking up the different components, this walks you through all those different pieces. And I'm guessing that is what many of you have done in the past, maybe by following the tutorial itself or by trying to do it on your own. I'm telling you that I think it is very useful for you to have the experience and understanding of what's going on behind the scenes, having done it by hand by following this tutorial. But once you have done that once on your own laptop or a dev machine to try it out on, I don't want you to ever do it again. There are much, much easier ways of doing this. If you're setting up the base deployment on a single machine on premises or some kind of VM environment, use the ArcGIS Enterprise Builder. It is a single installer that lays down all of the different components and wires everything up that I've talked about with a minimum of fuss and questions. It is a next style installer that asks you somewhere in the neighborhood of 7 questions, including what is your name, your email address, and your preferred administrator password. You walk away for half an hour to 45 minutes, depending on how new of a machine you have. Come back and the whole system is set up for you. Do not do that by hand, please. If you're deploying in the cloud, use one of the cloud builders that Jay also mentioned as part of the plenary this morning. If you're deploying in AWS, we have cloud formation templates. We have cloud builders, command line interfaces for doing this. If you're deploying in Microsoft Azure, we also have cloud builder tooling, both a graphical user interface that asks you a number of questions, such as how many machines do you want? What are the instance sizes? What is that administrator password that you would like to start the system with? Then you say go, you walk away. It spins up all the infrastructure for you because you're in the cloud and we can do that. And then you come back and your system is up and running. All of that built on top of technology such as Chef underneath the hood and PowerShell DSC. If you want that more fine-grained control, you want something that's repeatable and automatable instead of a graphical user interface, you can go into things like this as well. If you're working in an environment other than AWS and Azure, then you can use Chef directly there and PowerShell if that is your preference. Chef works both on Windows and Linux. PowerShell is a Windows-specific technology that integrates very nicely with the Microsoft ecosystem. All right, so we've talked about the base deployment. You're trying to figure out, do I need to scale out or do I not? Do I go multi-tiered from the beginning? Why is it that you would do that? So let's expand on that a little bit. So a couple of starting points to think about whether you need to scale out is to keep in mind, you can have any number of ArcGIS Server sites within your ArcGIS Enterprise deployment. The base deployment itself just has a single site that is your GIS server and your hosting server in one. For many of you, a single machine ArcGIS Enterprise deployment is probably just fine. You can do a lot of things with a single machine, power tens if not hundreds of users, maybe not all at once depending on what they're doing, but that's where you have to make a judgment call. Don't overcomplicate your deployment unnecessarily. If you can get away with a single machine deployment, go for it. There's nothing wrong with doing that, even in production environments. When you come to the conclusion that you do need to be able to scale out or you want to future-proof for the situation where that might happen, then keep in mind you can have multiple ArcGIS server sites, and then remember those different server roles. An ArcGIS server site is a generic term for a multi-machine grouping of ArcGIS Server machines. But those ArcGIS Server machines can do different things, right? ArcGIS Server is the software component that powers what? GeoAnalytics, Image Server, GeoEvent, as well as the traditional GIS Server. So when I say ArcGIS Server site, it can be any one of these. But there's lots of nuance, which is going to be the next 20 minutes. Okay, so if we're expanding out from the base deployment, one way of doing that is to add additional GIS server sites. We already have one as part of the base deployment, but you might want to add additional ones for some of the reasons that I mentioned before. Instead of having the hosting server site both do hosting duties as well as traditional mapping, you might want to add more of these. The other reason to add additional ArcGIS server sites is to add more capabilities, to add some of those real-time processing capabilities, those raster and imagery capabilities, and big data processing. They all behave slightly differently. So let's talk about what that means in the context of those different server roles. We'll start with the GIS server itself. You already have one of these. And if you need more, think about what it is you want those additional GIS server sites to actually do. Some common workloads that cause you to add additional GIS server sites to a deployment are listed here. Typically, most often it's about high volume map services. You have some foundational operational layers that everybody in your organization use on a daily basis. They keep getting pummeled, lots of requests, lots of CPU. You want to isolate those off. But there's other things like geoprocessing that can often benefit from being put on dedicated infrastructure. Geoprocessing can be incredibly powerful. You can run your own Python scripts. The GeoGP tools that come with the system, along with a lot of other things. And often those kinds of analyses are CPU, memory, and or I/O intensive. Instead of co-locating that kind of analysis with traditional map services, let's say, isolating them can prevent an analysis from all of a sudden making all of your maps run slowly. You don't want the one analysis to cause every single one of your layers, your map services, to all of a sudden draw at half speed. And then you might simply have other things like CPU-intensive route services or mission-critical services that you need to keep up at a higher SLA than other parts of the system. Now, a reason for creating additional server sites in the past have sometimes been that I have a lot of services. Maybe not necessarily services that are being used very often, but there's simply a lot of them. How many of you have hundreds of services in an ArcGIS server site? Now keep those hands up. How many of you wish that they used less memory? Emphatic waving from the back. I'm not going to get into detail on it here, but I just want to point out this new feature that's coming with ArcGIS Enterprise 10.7 in a couple of weeks, shared instances. Come to the What's New session later this week or come to the Enterprise area in the showcase and we can talk more about it. I point it out here because memory consumption should not have to be a reason for adding additional servers or additional sites to your deployment. If you have that problem today, this is the feature for you. I'm not going to ruin the surprise, but just point it out so you can keep an eye out for it. So what does it look like if I take that diagram that I had before of the base deployment and I want to add an additional site? Well, it could look something like this. Within the white box, you have your base deployment, those software components that form the nucleus of your ArcGIS Enterprise setup. You've got those web adapters, you've got your hosting server site, the portal, and the data store sitting underneath. Now we're simply attaching another site to the portal. That attachment is what we refer to as federation. You can have as many of these GIS server sites as you want. You could have a second site for mapping, then add a third site for geoprocessing. You can really keep going to do whatever it is that best fits your needs. So this is a way of doing workload separation at the site level. GIS servers, there's no restrictions on how many. Only one of those sites is your hosting server site. Each one of these sites can have one or more machines within them. Okay? When we move on to something like image server, there's two distinct capabilities that are provided by the image server portion of ArcGIS Server. There's what I would refer to as probably more traditional image server functionality, which is publishing out your dynamic image services, referencing data in place. Mosaic data sets, individual TIFFs, whatever it might be. So this is a way of serving out large collections of imagery and making them available for analysis as well as visualization. You can have any number of sites performing this task. Image server since 10.5 has also had another distinct set of capabilities, and that's what Vinay was showing you this morning in the plenary. That's the raster analytics portion of image server. This is about doing large volume distributed computing, processing, and analysis of your imagery and producing new persisted output. Right? Extracting some kind of information and producing a new output that is persisted and not just visualized in your map one time. You can only have one site doing raster analytics because it behaves in the form of you send a job from ArcGIS Pro, from the portal map viewer itself, or some kind of custom client, and that job is handed over to the raster analytics site for processing. The raster analytics site can be any size you want. 1 machine, 2 machines, 3 machines, n machines. But there can only be a single specific site that handles those raster analytics tasks. At 10.5 through 10.6, the results of your raster analytics will also be hosted out of the raster analytics site itself. Beginning at 10.6.1 and beyond, you can actually say where the results go. That's kind of an interesting nuance because let's say you're doing a lot of analysis, you're creating a lot of new outputs, they become image services of their own right. Well, you don't want future analysis to compete with resources from you being able to interact with and use the results of previous analysis. So beginning at 10.6.1, you can actually designate an image hosting site as well. That's something to keep in mind. So what does this look like? Again, if we have that base deployment within the white box, you can add an image server site that does both traditional serving out of image services as well as perform raster analytics, or you could go and add multiple sites. In this case, I have 2, one for dynamic image services and another image server site for performing raster analytics. I could continue adding other image server sites for those dynamic image services shown on the bottom side, but I would just have the one raster analytics site shown on the right-hand side. If we keep moving on to GeoAnalytics. GeoAnalytics Server you saw demoed on stage this morning as well, and it's all about processing of big data within your GIS. Big data means a lot of different things to a lot of different people. But in this case, I love the definition that we heard this morning, which is data that is too big for your traditional processes. If you're worried about an error 9999, if you're running a geoprocessing tool on your desktop using ArcMap or Pro, then you should probably consider something like GeoAnalytics because it's obviously too big for whatever it is you're trying to do. So GeoAnalytics Server provides distributed computing infrastructure as part of ArcGIS Enterprise. You have one GeoAnalytics Server site. Just like with raster analytics that I just talked about, it works on this job-based model. You fire off a job from your analysis client, whether it's Pro or from within the portal map viewer like Noah showed you in the plenary, and the portal hands that job over to the GeoAnalytics Server site. GeoAnalytics requires use of the spatiotemporal big data store. So remember when I talked about the ArcGIS data store, it had 3 different flavors. The relational, the tile cache, we already talked about as part of the base deployment. GeoAnalytics is one of the reasons why you might need to add a spatiotemporal big data store, the 3rd flavor of the ArcGIS data store component. That means there's 2 things you now need to keep in mind as you're architecting your configuration. You need to plan for the GeoAnalytics Server site itself, and then you need to plan for that data store. There's a lot of things that go into figuring out what is the proper sizing and deployment of GeoAnalytics Server. Often, when I talk to people who are new to thinking in terms of big data processing, there's a perception that more cores will make everything go faster. That is only true up to a certain point. You need to be able to keep those cores busy. That means you need to be able to have the data available. That means you have to have the data available in memory, because reading data from anywhere other than main memory is too slow to keep those cores busy. More often than not, you need more memory than you need more cores. With GeoAnalytics Server, it's been out since 10.5. There's been progressive improvements both to the architecture itself under the hood as well as adding additional tools. With 10.7 out here in a couple of weeks, there's been some significant improvement to the underlying core architecture. And I would encourage all of you, if you're using GeoAnalytics or you're looking to use GeoAnalytics, to go straight to 10.7. There's just so many improvements that you shouldn't look at anything else at this point in time. GeoAnalytics is about big data processing within your GIS. This is not a general purpose, I want to write my own Spark jobs kind of thing. If you know what that's all about, this is not that. This is about taking those tens of millions or hundreds of millions or even up to the billions of records within your GIS and being able to do processing against them. We recommend 2 deployment patterns for GeoAnalytics, a 1 machine site or a 3 machine site. Not 2, not 4, not 5, not anything else. Just 1 or 3 machines. There's a lot of reasons for that that go into the architecture. I mentioned there's a lot of variables that affect performance, and it's not just all about cores. Here are just some of the variables. This is where I say don't panic, again. I point this out to encourage you to do some prototyping. If you're interested in big data processing, to try to figure out exactly what does your problem look like in this regard, and what are the variables that you need to keep in mind. Data is not just data. It also depends on the data format and the location of that data. Some data is file-based. I thought it was awfully amusing when I first got into this that CSV files is the shape file of the big data world. It's the lingua franca. Everybody likes their CSV files. But there's a big difference between reading data from a file locally on the machine running GeoAnalytics versus a file sitting in S3 in the cloud versus reading data from a web service somewhere else. All of those things are very, very different. Your location of the data matters a lot. The LAN characteristics. When's the last time you worried about 100 megabit versus a gigabit versus a 10 gigabit LAN? It matters because, again, we need to keep those machines, those cores busy when we're doing processing. Having the data on an SSD versus a traditional hard drive. Don't use anything other than SSDs these days. The size of the data and so forth. Not all data is appropriate for GeoAnalytics. If you have data in the tens or hundreds of megabytes, it's probably faster to use a traditional tool because there's a startup cost to running one of these jobs. All right, so now that I've completely sold you on the idea of GeoAnalytics, what does it actually look like to put it into your deployment? There's now 2 new things that come in. That base deployment, we've added the spatial temporal big data store on the left-hand side, and then we've added that GeoAnalytics Server site down on the bottom right. Notice something key here. All of the data stores that come from ArcGIS Data Store are hooked up to the hosting server site. Might seem like a small thing, but I have lost count on the number of internal people within Esri and customers that I've talked to who hooked up the spatial temporal big data store to their GeoAnalytics server site. It seems pretty obvious, right? I'm using that data with that site. No, it's not how it works. Make sure you factor that into account, take that into account. Spatial temporal big data store is, in essence, a database of itself. That means you need to give it enough memory. You need to plan for that. The GeoAnalytics server site is just like any other ArcGIS server-based server role. You create a site and you hook it up to the portal. Remember I said you can either have a 1 machine site. If you're in the cloud, just use a really big instance. Don't overcomplicate things by using multiple machines. Just spin up a bigger instance size. If you're in a traditional IT environment where you don't necessarily have access to huge VMs, if your IT department will laugh at you if you come and say, just give me a 16-core box with 128 gigs of memory, then by all means, use a 3-machine setup instead. Use 3 smaller machines if that's what you have access to. But, again, if you have bigger machines available, it's much simpler to just use a really big machine. No need to go fancy just because it's a possibility. That brings us to the last of the 4 big server licensing roles that I'm going to cover here, which is GeoEvent Server. GeoEvent is fundamentally about real-time data processing. This is about being able to hook up to real-time feeds that report the status of something that's moving or the status of something that has a location where the attributes are changing and reacting to those changes in time, space, and values in real time. This is about doing geofencing and sending out alerts when something enters a restricted area. It's about keeping an eye on the temperature of that truck driving down the highway and making sure that it doesn't go above a certain point. Whatever it might be, if you need to react to something in real time, GeoEvent is what will be able to power that. For GeoEvent Server 10.5x and prior, the recommendation is to use single machine sites. You can have multiple single machine sites, so you can have one site handling one set of feeds and then another site handling another set of feeds. And each one of those sites has to be big enough to handle the peak load that you expect to come in. If you're dealing with predictable amounts of events, you always know that you're handling roughly 100 events per second. That's fairly simple to plan for. If you need to deal with feeds that have unpredictable peak loads, it gets a little bit trickier. You're going to have to make some assumptions about how big of a machine do I need to be able to handle those peaks without dropping events. A big thing about real-time processing is not just the real-time actions themselves, but also storing that data after you have acted upon it, enriched it with additional data, but then storing those results to process later on. Maybe process that data using GeoAnalytics, or simply pulling the data out and doing other kinds of analyses. If you're dealing with hundreds or even thousands of events per second, that adds up really, really quickly. You can store into traditional databases, but if you have a lot of data over a longer period of time, you will very likely want to use something that can handle that volume of data. That's the spatiotemporal big data store again. So that's the second reason why you might want to add the spatiotemporal big data store to your ArcGIS Enterprise deployment. So the simplest way of adding GeoEvent Server to your ArcGIS Enterprise deployment is a single machine site connected to your base deployment. Again, federated up to your portal. If you're dealing with large volumes of data, and large volumes of data in this sense is typically, if you have more than a few hundred events per second, you want to store that into the spatiotemporal big data store. A traditional database can simply not keep up with continually inserting that volume of data on an ongoing basis. So at that point, your diagram would expand out like this. If you're on 10.6, if you're on 10.5x or earlier with GeoEvent, you would scale out by adding additional GeoEvent server sites as needed. A single GeoEvent server can handle thousands of events per second. So unless you expect peak loads to go beyond that, you probably don't need to add additional sites. If you're on 10.6 or higher, then we recommend looking at multiple machine sites for GeoEvent as well. Makes it possible to scale out horizontally and deal with those peak loads, as well as adding a measure of resiliency to your deployment. All right. I've covered a lot of different things. It's almost already an hour, but I want to recap. And again, this is a text-heavy slide, so all of those pictures that you're taking, you can go home and point to this. This is the cheat sheet. You install ArcGIS Server, but then you make it into a GIS server, an image server, a GeoAnalytics server, or a GeoEvent server. Some of them you can have multiple sites of, others you can only have a single one. Raster Analytics and GeoAnalytics both follow the Highlander model. There can be only one. That's a test to see how many like their mid-80s classic movies. For the GIS server, it's simple. It scales horizontally as well as vertically, and you can have as many sites and as many machines as you want. The others get a little bit more nuanced. Before we finish up, I want to cover a couple of other topics that are somewhat related to what I've been going through here about the architecture. It's not directly architecture, but there's a couple of common misconceptions or old best practices that I want to update on. Do not use clusters. How many of you know what clusters are in the context of traditional ArcGIS Server? How many of you are still using clusters today? Stop. Clusters are discouraged on any version of ArcGIS Server. They were deprecated as of 10.5.1. We told you to stop. 10.7 no longer supports clusters. If you upgrade to 10.7 and you still have a multi-cluster site, we'll try to do the best thing we can and migrate you off, but you really should do that yourself before upgrading. The writing's been on the wall for a while on this. Please stop. For any one of you who don't know what I'm talking about, forget that I ever mentioned it. Do federate your ArcGIS Server sites. If you're coming from a pre-ArcGIS Enterprise world where there was just ArcGIS Server, you will probably still have some of these standalone ArcGIS Server sites. There's a lot of newer functionality that requires the modern deployment patterns and requires them to be federated with your portal. It's a best practice for single sign-on type things, as well as a lot of concrete technical features. Please do use the web adapter unless you truly have a good technical reason not to. Most of you who think you have a good technical reason not to, I disagree. It simplifies a lot of configuration. If you don't use the web adapter, there's just a lot of additional manual configuration that you will have to do yourself, and odds are good you're going to run into trouble. Then we have tech support cases, and none of us want that. This one is kind of interesting. Those of you who have hundreds of services today on a single ArcGIS Server site may have run into things like this. Without getting too much into SOC processes just now, if you have hundreds of services and you are getting strange out-of-memory type errors, even though there's plenty of memory left on your machines, you're running into, and you're running on Windows, by the way, you're running into a Windows-imposed limitation. You have two options to resolve this. One is to go and edit the registry. It's one of the most arcane registry settings you will ever find within the Windows registry, and that says quite a lot. You can do that. We have a KB article or tech support article that is available that walks you through how to do that. I mentioned shared instances before. Come to the What's New session. We'll talk about shared instances as part of ArcGIS Enterprise 10.7. It is a game changer. Absolute game changer if you have a lot of services and a lot of service instances. The takeaways that I would leave you with is understand what the base deployment of ArcGIS Enterprise is. What do you get with it? It's the portal, it's the server, it's the data stores, all configured together in the right manner. Don't overcomplicate things. Don't overcomplicate things unnecessarily. There's a time and place for complex architectures, and if you fit that need, there's nothing wrong with that. But if you're trying to support a small team or a department of 50 to 100 people, I'm going to say that you are better served by trying to stick to a one-machine deployment if you can, because it's just that much easier and simpler. Both with regard to how to install it using the Enterprise Builder, upgrading to future releases with the Enterprise Builder. It's not quite a one-click setup, but it's darn close. Don't upgrade by hand. Don't install by hand. Use the tooling and make it easier on yourselves. Stay up to date on best practices. I mentioned a couple of things here at the end. If you've been with us for a long time, what was a good practice in the early days of the current architecture, 10.1, 10.2, 10.3, does not necessarily mean that it's still a best practice. The technology has in many cases evolved since then. 10.6 and in particular 10.7 with things like shared instances start to change the dynamics of what it was a best practice before and now. ArcGIS Enterprise is designed for that federated server model. Doesn't mean standalone servers are going away at all, but there's just a lot of functionality that relies on that full ArcGIS Enterprise stack. vector tile layers, GeoAnalytics, raster analytics, the utility network, coming up in a future release, parcel management, all based on the full ArcGIS Enterprise stack. And then finally, those individual server roles. ArcGIS Server is not just ArcGIS Server. It depends on what role it's playing within the system. GIS Server, Image, GeoAnalytics, and GeoEvent are all different. I'll leave you with this one last slide. Remember, don't panic. That's a lot of information. By no means do I expect you to walk out of here being experts on all of this, but hopefully I gave you enough information to get started. Remember, the documentation has all of this information and a lot more. We want you to come by the Enterprise Showcase area throughout this week. Come ask us your questions. We're more than happy to help. Thank you very much.